Class 10, Chapter 1, Real Numbers, Exercise 1.1, Question number 5. Use Euclid's division lemma to show that the cube of any positive integer is either of the form 9m, 9m plus 1 or 9m plus 8 for some integer m. So, let us take x as a positive integer. According to the Euclid's division lemma, we can represent x as bq plus r, where r is greater than equal to 0 and less than b. In the question, we have been given cubes of three different forms, which are 9m, 9m plus 1 and 9m plus 8. To show that the cubes of x, which is a positive integer, can be of either of these three forms, we have to take three different values of x, which means we must first select three different values of r, which can be 0, 1 and 2. We can see that 0, 1 and 2 are greater than equal to 0 and less than 3. Therefore, we must select b as 3. Substituting the value of b in the equation x equals bq plus r, we can write x as 3q plus r, where r can take the values 0, 1 or 2. We had said that we must take at least three values of x and find their cubes. But now we can say that only these three values of x will be sufficient to prove that their cubes are of the form 9m, 9m plus 1 or 9m plus 8. This is because any positive integer can be represented in the form 3q plus r. Now let us take the three possibilities of x, which are 3q, 3q plus 1 and 3q plus 2. We must show that these three values of x can give a cube which is either of the form 9m, 9m plus 1 or 9m plus 8. We will take the first possibility of x, which is 3q. Since we need to find the cube of the positive integer x, we will take a cube on both sides of the equation, which gives us 3q whole cube. 3q whole cube can be represented as 27q cube. Now we need to show that x cube can be represented in either of the forms 9m, 9m plus 1 or 9m plus 8. Which means in x cube we must find at least one multiple of 9. So 27q cube can be written as 9 times 3q cube, which is obviously a multiple of 9. But is 3q cube an integer? Let's see. By the closure property of integers, if we multiply three integers, it will give an integer. So if we multiply q by itself 3 times, q cube will be an integer. Now we must multiply q cube, which is an integer, with another integer 3. So 3 times q cube gives us 3q cube, which is an integer. So 3q cube can be represented as m, which is an integer, and x cube can be represented as 9m. So we can see that when we take the value of x as 3q, its cube is of the form 9m. Moving on to the next possibility of x, which is 3q plus 1, we will take a cube on both sides of the equation, which gives us x cube equals 3q plus 1 whole cube. Now we will use the expansion formula a plus b whole cube equals a cube plus 3a square b plus 3ab square plus b cube to expand 3q plus 1 whole cube. By using this expansion formula, 3q plus 1 whole cube can be written as 27q cube plus 27q square plus 9q plus 1. In this expression, we can see that 27q cube, 27q square and 9q are all multiples of 9. So by taking 9 common, we can write x cube as 9 times 3q cube plus 3q square plus q plus 1. Again, by the closure property of integers, 3q cube plus 3q square plus q must be an integer, because when integers are added, it always gives an integer. Therefore, 3q cube plus 3q square plus q can be written as m, and x cube can be written as 9m plus 1. So, we can see that when we take the value of x as 3q plus 1, its cube is of the form 9m plus 1. Moving on to the next possibility of x, which is 3q plus 2, we will take a cube on both sides of the equation, which gives us x cube equals 3q plus 2 whole cube. Again, using the expansion formula, a plus b whole cube equals a cube plus 3a square b plus 3ab square plus b cube, we can write 3q plus 2 whole cube as 27q cube plus 54q square plus 36q plus 8. In this expression, 27q cube, 54q square and 36q are all multiples of 9. So, by taking 9 common, we can write x cube as x cube equals 9 times 3q cube plus 6q square plus 4q plus 8. Now, 3q cube plus 6q square plus 4q must be an integer by the closure property of integers. Hence, we can write 3q cube plus 6q square plus 4q as m, which is an integer, and x cube can be represented as 9m plus 8. So, here we can see that when the value of x is taken as 3q plus 2, it gives us the cube, which is of the form 9m plus 8. Therefore, we have proved that the cube of any positive integer x is always of the form of either 9m, 9m plus 1 or 9m plus 8.